Okay, so today we're going to look at conservation of momentum. The last section we were looking at conservation of energy. Okay, that was where we were using saying that potential energy and kinetic energy must remain constant within a system, and if there were two different scenarios, a before and an after, that the energy before had to equal the energy after. Okay, well, this is moving along. We're talking about now conservation of momentum. So let's quickly revise. What is momentum? Momentum is the quantity of motion of a moving body. Okay, so it's the quantity of motion in a moving body. And then just going to need this later on. Impulse is the change in momentum. Okay, so momentum is the quantity of motion. Impulse is the change in the quantity of motion. So momentum is summed up in the formula force is equal to mass times acceleration. Okay, so the acceleration, remember, is rate of change of velocity and your mass, which affects it, obviously. So if we looked at Newton's second law, it says the rate of change of momentum is proportional to the force applied. Okay, so in other words, change in velocity, change in direction, change in acceleration, and that all depends on its direct relationship between the force applied to a body and the result on the body. Okay, and a quick revision of Newton's first law, that a body in motion will stay in motion unless an external force is applied. So in other words, once something, a ball, let's say it's rolling on the ground, if there's no friction, no air resistance and nothing to stop it, it will keep going. Okay, so when you put these together, this can be applied to the law of conservation of momentum. That it seems a little bit obvious when you think that momentum, what is the momentum again? Go back up and check it. What is momentum? The quantity of motion. So we can talk about motion, or motion, which is a type, which is like movement, which is a kinetic energy. So the laws of energy, kinetic energy, can be applied here to the laws of conservation of momentum. So in the absence of an external force in a given direction, momentum is conserved in a closed system. What are we talking about here? If you have a ball that is rolling along a floor, okay, and if you have a force that hits it from the side, the ball will respond by moving to the side, by being deflected. However, you can look at the first law where it says a body in motion will stay in motion unless an external force is applied to that ball, and saying that the movement is still going to keep going because there's nothing to stop it. And then a closed system means that there's nothing external influencing it. So mathematically, what does that mean? Well, we know that force is equal to mass times acceleration. And when we're using our vectors, we can say force in any given direction is equal to mass times the acceleration in a given direction. But your acceleration, what is acceleration? Remember, acceleration is the rate of change of velocity. So that's your final velocity minus your initial velocity divided by the time taken. So the change in velocity divided by the time is your acceleration. So I can now put this formula into this equation, and I get force is equal to mass times v minus u over t. Multiply both sides by t, and I get the force times time is equal to mass times v minus u. Now, force by time is impulse. Remember, impulse was the rate of change of momentum. So that's going to be here, your force times time. Okay, so we can say that impulse is equal to mass times the final velocity minus the initial velocity, and the units are newtons per second. Newton seconds. So impulse is equal to mass times the change in velocity. Okay, and then that can be summed up in the law of conservation of momentum insofar as for any collision occurring in an isolated system, i.e. no external forces, the momentum is conserved. So what does that mean? It means that the sum of the momentum before a collision is equal to the sum of the momentum after a collision. And I wanted this in the middle here. There you go. Now, okay, so now I have two formulae that we're going to use in this section. The impulse is mass times the change of velocity, and then the conservation of momentum. What does that read? The mass of the first object times its initial velocity plus the mass of the second object times its initial velocity is equal to the mass of the first object times its final velocity plus the mass of the second object times its final velocity. Okay, when you see it in place, you'll understand it. It's quite clear. Simple example, first of all, a golf ball of mass 0.1. Does that want a space there? That wants a space, I think. Okay, so a golf ball of mass 0.1 kilograms is hit from rest so that immediately after impact it moves horizontally at 60 meters per second. Find the impulse imparted by the blow. So, be careful here. When it says it moves horizontally, it means that your movement is a vector with only an I component. We're back to vectors here. Okay, so we have a mass of 0.1 kilograms, an initial velocity of 0 meters per second, and a final velocity of 60 I meters per second. So I can use the formula I equals mass times the change in velocity, and I get that the impulse is 6I Newton seconds. Straightforward enough. Okay, let's look at our second example. So we have a tennis ball of mass 0.5 kilograms moving horizontally at 8 meters per second, and a player hits it so that it leaves the racket at 18 meters per second in the opposite direction. Find the impulse imparted by the ball by the stroke. Okay, so again, we're talking about movement that is horizontal, and we're talking about vectors, so we're talking about directions here. So that means our directions are always going to be I, because it's only horizontal movement, and it's going to be plus moving in the positive direction and negative moving in the negative direction. So if we look at the mass of the ball, that's going to be 0.05 kilograms. The initial velocity is 8I meters per second, and the final velocity is minus 18I meters per second. Why is it minus 18I? Because it's moving in the opposite direction. I put those numbers into the formula. I is equal to mass times the change in velocity. And I get that the impulse imparted is minus 0.13 I Newton seconds. Now remember, that means the value or the quantity of impulse is 1.3 Newton seconds, but the impulse, because it's a vector, is minus 1.3 I Newton seconds. It's telling you about the direction of it as well. Okay, let's look at our third example. A bullet of mass 0.1 kilograms travels horizontally with a speed of 150 meters per second until it enters a block of wood which rests on a smooth horizontal table. The bullet emerges from the other end of the block with speed 100 meters per second. If the block has a mass of 2 kilograms, find the speed of the block. So we're looking for the speed of the block after impact. Also, find the impact imparted by the bullet onto the block and vice versa. Okay. So before I decide how I'm going to do this, I'm going to write down all the information I have. So for the bullet, I have a mass of 0.1 and I have an initial velocity of 150 I meters per second. And then for the block, I have a mass of 2 kilograms and an initial velocity which is 0 and a final velocity which is v. So again, quickly, let's look over this. The bullet has a mass of 0.1 kilograms, an initial velocity of 150 I meters per second, and a final velocity of 100 meters per second. Okay, the block has a mass of 2 kilograms, an initial velocity of 0 I meters per second, and a final velocity of v meters per second. Okay, so I can use here my law of conservation of momentum. So that's this formula here. And I can write that down. Okay, and sub it in. I should probably write it down here. Let me see. Right, so I'm going to write that down there. There you go. Okay, so I'm going to, and then just sub in my M1, U1, M2, U2, M1, V1, M2, V2. And I can work that out, and I get a velocity of 2.5 I meters per second. Okay. Now, to get the impulse, which we're also asked to calculate, remember your impulse is equal to the mass times the change in velocity. Okay, so how do I know which one? It says the impulse imparted by the bullet. So the bullet is what we're looking at, the impulse from the bullet. So that's 0.1, which is the mass, and then the change in velocity, which is minus 50I, and that gives us minus 5I Newton seconds.